This small town did not know that they were being exposed to toxins for years. You may even have these toxins in your blood at this moment. Welcome to Portsmouth, New Hampshire. The Pfas Air Force Base is located northwest of Portsmouth. It was a site of military activity until 1991, where it was declared a Superfund site for high levels of contamination. Military firefighters regularly use aqueous fire-forming foam, known as AFFF, to extinguish aircraft fires during training or on duty. AFFF contains Pfas, a group of chemicals found in everyday products. Pfas have strong molecular bonds that repel oil, water, and stains. They can withstand extreme heat and are called forever chemicals for their ability to last in the body or environment for a long time. There are nearly 5,000 different kinds of Pfas, and exposure is linked to health issues such as thyroid disease, kidney cancer, and liver damage. But what does this mean for the consumption of fish and shellfish that live in these waters? What occurred at Pfas Air Force Base was extreme runoff of AFFF into nearby bodies of water, affecting the local town's water and soil. At the Chen Lab, we are studying a particular body of water near Pfas Air Force Base known as the Great Bay Estuary. The Great Bay Estuary holds a diverse set of species and serves as a nursing ground for marine species. Contaminants in their food or water can be transferred to birds and coastal species that we eat. The goal of this project is to investigate the patterns and profiles of Pfas in marine food webs. Our lab touches on two concepts, bioaccumulation and biomagnification of Pfas in marine ecosystems. Bioaccumulation occurs when an organism consumes or absorbs a contaminant. Multiple exposure events, such as a fish eating contaminated plankton, can add up and accumulate in greater amounts over time. Biomagnification involves how contaminants move in the greater food chain through water or food exposure. At the bottom of the food chain, algae are exposed to a contaminant. An insect eats a lot of algae, increasing the amount of contaminant in their tissue. As it moves up to the bigger predators, the concentration of contaminant increases. A human, which is at the top of the food chain, eats the big fish and ends up with the highest concentration of toxin in the body. I am currently working with Nate to sample and test our bivalve collection for Pfas. This involves going to parts of the Great Bay Estuary and collecting bivalves such as soft-shell clams, mussels, and oysters. I take the bivalves and create tissue composites and send them over to be analyzed for Pfas and other measurements such as organic carbon, nitrogen, and iron. These bivalves are important because they are primary consumers, meaning that they eat the plant life in the estuary. They are also direct sources of food we eat. So far, we've collected bivalves, water, and soil samples to test for Pfas. Later stages of our project include using species and higher trophic levels, such as small fish, to measure bioaccumulation across different environments. Portsmouth is not the only town with a Pfas contamination issue. Through our research, we hope in establishing scientific methods for studying Pfas in marine environments and providing information to the community about Pfas exposure in seafood.